I'm Adam Wilson. I'm going to be talking about Replicant, a library I've been working on written in Rust for synchronizing data between local devices and remote servers, mainly aimed at audio plugins and also mobile apps and the web. And it synchronizes between local SQLite databases and remote Postgres databases using JSON. So a bit of background on me. I founded a company called Node Audio a number of years ago. I've been in the audio development space for about 11 years. And before that, I was a server-side web developer. And I'm also a music producer. This talk is building on a talk, or it's kind of a follow-on from a talk I gave last year, which was on data synchronization for audio plugins in general and exploring different libraries and the concept. So if you want to know more about that, go and check my talk from last year, which is on YouTube. So why did I decide to build something when the conclusion of that talk last year was, I don't want to build something. I just want to use something that someone else has built. Thank you very much. I want to focus on making cool stuff and making music. But basically nothing really worked, or it was too expensive or proprietary. And the proprietary thing really came out of my learning, which I talked about last year, which was I was relying on a third-party library and their closed-source synchronization solution, which then became deprecated. So after a few months of integrating it, the deprecation was announced, and yeah, not very happy. So I wanted something that would never be deprecated, that would be based on really boring open source technologies that are not going to go away. And another reason to start building something was Claude Code came on the scene. And I was really curious about it, and I thought, maybe this could help me to build the thing that I've been wanting to exist. The main inspiration, if you've got any familiarity with this world of synchronized databases, was CouchDB, which I used in a mobile app a long time ago, and I really liked it. It's really easy to use as a developer, and it's really lightweight. It's really cheap to run on a server, unlike some of these other distributed databases, which cost a lot to run. And there were some other inspirations, but CouchDB is the main one. The main thing to note, though, is that the system I wanted to build doesn't have to be a fully distributed database. It can just be what's called a server authoritative system, where the server is always telling everyone else what is the current state. The use case is, imagine you've got a plugin on a laptop, and you come up with a really cool preset. Let's say it's a modular synth or something really complex that's hard to replicate. But then you've got like a studio computer and you want to use that same preset there. So what do? Okay, you have to find where the presets are, email it to yourself, load it again. And then let's say you've got this same synth on an iPad. You've got it's icky and complicated and kind of really old school these days. Even 10 years ago, this was old school. So that's the kind of overall use case from a user's perspective. Digging down into the details a little bit, for the particular use case I'm thinking of, I want to cause minimal friction to users or no friction. So I don't want them to have to think of a password. So in this case, we already have their email address from our licensing system. So I just want to identify them just on their email address, or it could be a username. And also if it was a mobile app on the web, we can use Apple or Google Auth or some other authentication to grab their email address. The type of data is presets, it's document type, presets or a similar kind of thing where it's like what you call a document, like just a blob of data. It's not relational. But where the relational bit is kind of outside that document because you've got multiple users and you can have a user that owns something, but they want to share it with someone else. So you can have kind of different permissions levels. So some people can view things, some people can edit them, that kind of thing. One really important consideration, which kind of differentiates it from some of the commercially available solutions, is really minimal security requirements. Like the kind of stuff I'm wanting to store is just like fun stuff, basically. So no sensitive data. So the more technical requirements are that it obviously needs to be cross-platform. As I mentioned, I don't want to be relying on any proprietary technology. It needs to be thread safe if it's going to be in an audio plugin. Also, if you've got multiple instances of the same plugin open, you want to be able to have multiple, you want to have concurrent access to the database. And I want it to be easy to use both for users and developers. Just time check. So I chose Rust because it's cross-platform. It's got really great library support for networking and databases. For example, there's a library I'm using called SQLX, which allows me to share code between SQLite and Postgres calls. It handles migrations, which is really handy when you're developing or adding features. Rust, as you probably know, has sort of strong stability and security guarantees. And one of the biggest ones is being able to share code between the client and the server. So Rust is great for building servers. And in terms of the client code, we can use the foreign function interface, which basically makes it look like a C library. So you can use it from C++ or pretty much any language you can think of. So into some of the sort of details of what I've been building. So in terms of networking, we're only using WebSockets, really, and that's partly because it's quick, it's bidirectional. We can have the server send messages to the client, which become events, so you can then display them to your users. And it also means we can create one secure connection. And then we have this persistent connection, this persistent channel where we can have messages going backwards and forwards. So there isn't really a REST API yet, but maybe in the future if we need it. A bit more details about security. So as I mentioned, users will be identified by email or maybe username only. But I wanted it to have some level of security, so I was recommended something called HMAC, which is hash-based message authentication code. So that's kind of like an application level security thing. So it's something you've probably seen a lot in various web services where you get an API key and a secret, which is usually just revealed once and then you have to save it somewhere. So it's that kind of system. We store these in plain text on the remote database, so that might raise some security concerns amongst some people, but hey, I'm not, this is designed to store sensitive data, so I think that's okay for now. Thread safety is often, the big question in, when you talk about libraries and things to audio developers. So because we've written this in Rust, we have kind of built-in guarantees that things are going to be thread safe. So we're using Rust channels and mutexes internally. And in terms of callbacks and events, we have basically when different events are detected, we put them onto a queue, and then it's up to the caller to call this a function called process events, which will basically iterate through the messages on the queue and call any callbacks that you've set up. And so what this allows you to do is basically guarantee that everything that deals with events is going to be on one thread, so usually the main or the message thread. So for example, if this was in a Juice plugin, we've got a Juice wrapper where it basically calls this on a timer. So as long as all your callbacks are set up from the message thread, you're going to be fine, and you're not going to need locks or anything fancy like that. So a quick look inside a document. So we've got owner, we've got the content, which is JSON blob. So if you're using Juice, you would need to kind of convert your value tree XML stuff into JSON. We're deriving the title from the content just so that we can easily search through, because remember, this is like an SQL database, but we've got a JSON blob inside it. So we're just pulling the title out just for easy searching. And these two, synchrovision and content hash, are basically for the conflict detection and resolution, which I'll go into in a sec. And we've got usual kind of timestamps. And we've got a deleted at timestamp, which is basically like a soft delete. So if a document is marked as deleted, it's not shown anymore, but you can get it back if you need to. So we got various callbacks or events, like, obvious stuff really, like document added, updated, or deleted, and the synchronization state and the connection state, so you can update your UI according to what's happening in the background. So this is kind of like the meat of this, what this library is intended to do. So imagine if you're working on something and you're online and then you go offline, you're on the train or your internet goes or whatever. So the basic flow is, you make edits, and then when the user saves or something's updated, it creates a JSON patch, which is a bit like Git, like a Git diff basically in JSON, and adds that to a queue. And then when you go online, it merges those patches together and sends them to the server, and then the server attempts to apply that patch and then broadcasts that to all the other clients connected. Which is fine, that's all good, not too difficult. But sometimes there are conflicts. So you might go offline and have two users operating on the same document, and the first user's change gets merged in without a problem, and then the second user's change causes a conflict. So we use this content hash basically to hash the state that the server last agreed on. So that's stored locally, and then when a patch is sent to the server, it's sent along with this content hash and the sort of revision number which we think we're at. And if both of those match, then we can merge, no problem. But if they don't match, then we've got a conflict. At that point, we try and merge the two. So we're using what's called operational transforms. It's a bit like Git again. It tries to do a sort of simple merge, nothing too complex. So like say if you've got an array and you're changing one element and adding another element, or removing one, and they don't interfere with each other, then we can do that. But if they do, then we raise it as a conflict. So if we can merge, great, we just do the merge and carry on. But if it fails, we reject the oldest one. So last write wins. So the most recent change wins the race. And then we broadcast that state to all the clients, and they converge. And hopefully everyone's happy at that point. I've kind of gone through this a bit more quickly than I planned to, but we've got a little video. So this is, I'm not sure which button I pressed to get this going. Can anyone tell me which button I pressed to play the video? Oh yeah. So here, is it playing? Or I just paused it. Yeah. So we've got, this is like a terminal app, terminal demo app, just like a to-do list basically. So we've got two separate databases and one server, but both connected via WebSockets. And either side does something, and it's almost immediately reflected in the other side. And then after we've done a few things, we go offline. So I'm going to stop the server, and then we start to get messages saying connection failed, and then we carry on doing stuff. We change apples to oranges on this side, and we add a new item on the right side. Let that happen. And then, yeah, we create a new thing here. And then we go online again. And then they converge. And that's basically the whole point of it. So that's a quick demo. Oh, that's gone blue. They were meant to be white. So yeah, I've just published it on GitHub last night. It's still in kind of pre-alpha stage. There's still a fair bit to do on it, but I'm fairly happy with where it's at. And I'm very soon going to publish it on Crates.io for people doing, wanting to use it in Rust projects. Please get in touch if you want to try it or get involved. I'd really love to collaborate with other people that want this thing to be great. That's all. Thanks for listening.